Here we're trying to maximize a company's revenue based on a formula that their research has provided. So the first thing I want to do is take a look at this revenue equation and the corresponding constraint equation. Remember, we're not just maximizing the revenue here. We're maximizing the revenue based on the company's constraints that they only have $840,000 to spend on advertising, and that their TV and social media ad campaigns have different costs associated with them. So, in terms of making a constraint equation, you'll notice that each TV campaign costs $40,000, social media campaigns cost $20,000, and we've decided that X and Y would represent the number of these campaigns, respectively. Therefore, we can create this constraint equation, which basically, if you read it left to right, says money spent on TV plus money spent on social media equals total money spent on advertising. Now, before I use these for my constraint and revenue equations, something occurred to me. They have really big numbers with lots of zeros in them. So I decided to take 3 zeros off of every number, and now what I have is a revenue equation in thousands of dollars, not just dollars. So I'll have to remember that my revenue equation represents thousands of dollars moving forward. I took the constraint equation and set it equal to 0, as one does, in order to set up the Lagrange function. And now it's just a matter of algebra and partial derivatives. I distributed the 40 and distributed the lambda. And as usual, took my 3 partial derivatives, and I am now about to set them equal to 0. I recommend hitting pause and confirming that the partial derivatives are correct. Now, setting my partial derivatives equal to 0 leaves me a system of equations that I need to solve for x, y, lambda. Most importantly, I need to solve for x and y. Now, how you go about the algebra is, of course, up to you as a student. I'll share a little bit about what I did. I rearranged some of the letters in the equation so that they would be in more of a standard form. And at this point, this is totally optional, but I just happened to notice, because I notice things like this, that every single coefficient in this problem is divisible by either 40 or 20, depending on the equation. So I think I divided the top equation by 40 and the bottom 2 equations by 20. This is completely optional, but sure cuts down on your work. Now, I solved for x, y, and lambda and got these values, and how you go about that is, of course, completely up to you as well, but you can always solve for them using matrix inverses, which I alluded to in the last problem. Now that we know x, y, and lambda, we can find the revenue for our particular x and y value. Remember, we don't much care about lambda in a Calculus 2 class. So plugging in 19 and 4 gave me 61040 as my revenue. But let's not forget, that revenue is in thousands of dollars. So this represents $61040,000. By the way, that's about $6.1 million. And therefore, my conclusion is that I can maximize my revenue and get about $6.1 million if we have 19 TV ad campaigns and 4 social media campaigns.